Okay, ladies and gentlemen, we're going to talk about continuity. Now, continuity should sound familiar. It sounds a lot like the word continuous. A graph that is continuous is a graph that I can take my pen at one end, I can go all the way to the other end without ever lifting up my pen or having any issues. Now, on the other hand, if I have to follow the graph and then pick up my pen, move it somewhere else, and start again, that would be discontinuous. There are three conditions for continuity. The first condition of continuity is that f of a must exist. Now you'll notice I have y up here. Let's change that to f of x. And here's y, so let's change it to f of x because that's something we do on a regular basis. So f of a exists. The next one is as the limit of f of x as x approaches a also has to exist. Finally, f of a equals the limit of f of x as x approaches a. Those three conditions must be met for there to be continuity. Now, the first one is going to be very easy to explain. The second two are probably including things that you've never seen before. But let's find an easy way to name the biggest problems or the biggest offenders. Whereas this one is definitely continuous. This is certainly not continuous, and the reason it's not continuous is because it approaches this center bar right here, which is an asymptote. So if it approaches an asymptote, now an asymptote we should all know is something the graph approaches but never ever touches. Kind of remember that as we start talking about limits. So this is not continuous because it has asymptotic discontinuity. A lot of times we also call this infinite discontinuity because, of course, it goes to infinity. It goes up to infinity, down to infinity. We have all sorts of infinite numbers of problems. Now, this one is going to be another problem because as I pull up here, I have to jump over a hole. So in this case, we have what's called point discontinuity, certainly not continuous. So point discontinuity or removable discontinuity. Now, by the way, it's called removable because if I were to factor this up atop, that would be x minus 1, x plus 1, all over x minus 1. Now, that means that this and this cancel out, leaving this as the only zero here at negative 1. It's removable, but you'll notice if you try to graph this, you'll still have a hole right there at 1. It may not look like it, but try going and finding that spot. It'll disappear. Now, another type of discontinuity is step discontinuity or jump. Step or jump discontinuity because the graph literally comes up and you jump down to somewhere else. Now, it's different from asymptotic discontinuity because it's not going forever in one direction then forever in some other direction. It's simply jumping from one place to the next. Another common form of this is a step function, where it moves up in a stair-step type pattern. It's greatest integer function. Has double brackets. It's called the greatest integer function, also known as a step function. So step discontinuity slash jump, asymptotic or infinite, and then point discontinuity. There are the three conditions. With that, we need to talk about limits.